This lesson explains the two remaining fundamental data types and explains some of the relationships among the various data types. Java has a non-arithmetic data type. It can only take on one of two values. It's the Boolean data type and is always set to either true or false. Now, the names true and false are both keywords in the language. They're the only things that you can assign to a Boolean data type. You can't use numeric values of 1 or 0 for logical operations like you can in C. Conceptually, the Boolean data type is 1 bit wide, but that doesn't matter because you can't use it in arithmetic anyway. There is one last data type. You can actually argue that it's not one of the data types of Java. All it can do is hold the address of an object. You can't even set its value to an object of the incorrect type. All you can do is set its value to null or to the address of an appropriate type of object, and then use it to refer to that object. Whenever you declare a data item, whether it's inside or outside of a method, and you don't specify an initial value for it, Java initializes it for you. All of the numeric data types are initialized to 0. This is true for both integers and real numbers. The Boolean data types are initialized to false. Unless you specify the address of an object to be stored in them, all references are initially set to null. Null is another keyword of the Java language. For the arithmetic types, you can convert data from one type to another by simply assigning the data from one to the other. If the two types are not the same, you'll either be widening or narrowing the data. If you're widening the data, you're making it larger. If there is more than enough room in the receiving field to hold all possible values of the originating field, then you're said to be widening the data. There's no possible loss of data, so Java allows you to do this directly. For example, copying a short value into an int, you will never lose any data because an int can contain everything that can fit into a short. On the other hand, if you're reducing the size of the data, you are narrowing the data and could trim the value when it's copied into the new location. For example, copying an int value into a short value could trim the actual data if the value stored in the int was too large to fit into the short. For example, copying an int value into a short value would trim the actual data if the value stored in the int was too large to fit into a short. When you do this, the Java compiler will require that you cast the assignment to indicate that you realize you are narrowing the data and may cause some sort of inaccuracy. For example, here we have a short and an int. Notice that the value from the short to the int can be copied without any special notation, but the copy from the int into the short requires that you precede the source of the data with a cast, which means that you are forcing the data to be a smaller size. Oh, by the way, if you're not sure, you don't have to worry about using a cast. If you don't use a cast and you write a line of code that's narrowing the data, the Java compiler will flag the line for you, and you can either add the cast so the compiler will know that you meant to do it, or you can change the code so no loss of data is possible.